Facebook page of the conference, so please follow us also on YouTube. And now we are continuing with our information technologist sessions locally. And our first presenter, Darius will make presentation on player type simulation in gamified applications.
So hello everybody, I'm Darius and I will present my paper on player type simulation in gamified applications. So first, what is gamification? Gamification is putting non-game context into non-game, putting game mechanics in non-game context. So basically transforming our usual applications like project management systems to have some game resemblance. So we can model such system in different ways, for example, like with UML, GAM, machinations, or other formal methods. For this research, we will actually use Hexad player type taxonomy. So we will divide all players into 6 types, which are socializers, free spirits, achievers, philanthropists, players, and disruptors. So for modeling, we will use our proposed method, which is URA for short, or user actions, rules, entities, and interfaces. So basically a combination of different types of nodes which are linked together and possibly form a directional graph. So we will simulate a system called the Oil Trader, which is actually a simulator of market trading, and it has a leaderboard and basically a trading window and few more elements. So in general, between the experiment and control groups, what we will have is that in the leaderboard, we will introduce 3 additional motivational factors, which are streak, biggest win, and biggest loss. So the model can be represented in such a format. So the user is definitely in the center of the system and can pick one of 3 actions, which are buy, sustain, or sell shares. And there are 3 rules which represent all the game logic, 3 entities which encompass all data for this model, and 2 interfaces which return data back to the user. So if you want to simulate the model is not enough at its current state, so we need to add additional elements, like basically an agent element, which is a set of 4 functions. A pick, the function which defines which is the next action what the user takes. A key generally presents a key for the current state. A playing is actually says, do we want does the player want to continue playing? And a feedback basically is a return, a feedback signal back to the agent to actually reevaluate its success after each round. So a playing we can represent through a numerical function, mi, which if it's positive, we would say it's the player should continue playing, and if it's otherwise, the player should stop playing. So we can choose any model for this simulation. We actually build such model where we have the first member, which is the previous motivation, and then the second member is actually represents the sum of all motivational factors, and the third element is actually a constant decay, a constant of decay, which actually makes sure that our motivations runs out after some time. And we offer such formula to actually compute the decay constant. So firstly, we random seed the motivation from 0 to 100 in random values, and when for the number of factors is different between control and experiment group. So in control group we have 3 and 6 motivational factors in experiment group. So for each player, we randomly assigned a wave. For each factor, add a wave. For each agent randomly between -1 and 1. And so each factor also has an element O, which is dependent on each round outcome. As well, we choose for Sn and tau constants. We add for these parameters. We choose 4, and we say that actually the model scale for the impact scale of each factor is actually equal, and the decay factor is 2e based on that function. So we run a simulation with 1,000 agents and gathered all the data. Now we need to classify those agents into different player types. So what we do, we first define our player types, which we logically what weights in a perfect world would be for each player type. And then we compute our current agent random seeded waves to basically compute the distance between those 2 points. And when we choose the one, we say that the player type is that one which actually is closest to our perfectly chosen player types. So the results of this type of simulations, what we see first on the right, we see a mixed column. So basically if we sum up and take the average of all members, so what we get is there is no significant difference, but if we separate based on player types, we see that there are differences between different player types. So the conclusions are that the proposed method for simulating gamified systems. Simulations allow us to evaluate gamified element effects on each player type. The critique for this method right now is that actually people are cannot be easily put into one psychological player type. So in reality, they are mixed. So we need a more fuzzy-like approach to actually choose the player typology. So these conclusions may spur the development of novel classification taxonomies and new ways to simulate and evaluate gamified systems. So thank you, and I welcome some questions from you.
Any questions? Questions, please. Okay.
Player type is the given of player or is it class?
What again?
So I see there psychological or
Yeah, it's psychological types, and in logically the hexacle questionnaire actually divides into 6 player types, which are psychological. But in this case, we actually, based on the descriptions, we chose the values which closely represents those players.
okay.
So it's not really players. The second step is actually comparing these results to actually match the those which we could monitor from real experiments with real people. So that basically train our model and configure it to work properly.
Any more questions? Okay, Darius, thank you for your presentation. And our next presenter, Žygimantas Kaupas.
Hello all, my name is Žygimantas Kaupas, and today I'm going to talk about end-user license agreement and its impact on information security. So first of all, the content of my presentation. So at the start, I'm going to speak about the EULA in general. Then I will introduce you to the experiment I have made, and finally there will be some analysis of the results and some conclusions. So let's start from the definition. So EULA is a legal agreement between the software developer and the user of that application. This was designed as some sort of insurance for the software developer if something goes wrong. You have probably seen this acceptance window many times, but that's not the only way how users could accept the end-user license agreement. For example, just by opening the package or downloading the application, this could be classified as an acceptance method. I'm not sure how many of you have read the EULA at least once in your lifetime, but it's usually very, very, very long. On average, it's 3,000 words, so that will be like 11 pages on double spacing. But sometimes this number goes to real extremes. For example, in 2012, the PayPal's EULA was more than 36,000 words. So for you better understanding, it's Shakespeare's Macbeth. It's only 30 plus, so it's really long. And even those who want to read this document, so they usually face a difficult legal terminology, so it's really hard to understand what is written there. So even some big names in software companies like to, well, use EULA for their own purposes. So for example, if you want to use the Cortana user assistant in Microsoft, you will be asked to agree with sharing all your data. For example, browsing history, what files do you have, what programs do you use, etc. Facebook, on the other hand, claims that it could use everything you post in it for their own reasons. So for example, your photo could be used as an advertising without any warning for you. And last but not least, Google says that it could change the license agreement text anytime without any additional warning. As you might guess, there weren't many researches done regarding this. I would like to mention one private initiative that was made in 2005. Software development company PC Pitstop include the $1,000 prize in their EULA text. So the winner came only after 4 months and 3,000 downloads. So not very good statistics. And if you want to have some software solutions like automatic analyzers, there aren't almost none. Just a few examples like EULA Analyzer, but they are no longer developed, so they are really outdated and with limited functionality. So my experiment was made last year. For this experiment, the first year students of informatics faculty were selected. It's expected for them to have better than average computer literacy skills. They were presented with a knowledge testing application Quiza, which was developed for Windows and Android platforms. If they successfully passed the test in that application, they were rewarded with some bonus content. And the same bonus content could be accessed via an alternative link in the EULA text. If the user decided to install that application and well, try its luck with the test, so besides the standard functionality, the application collected some unique data about their system. In this case, this was data about hard drive devices like serial number, free space, use space, etc., and sent it to me. For this experiment, the special EULA was developed, which had all the negative aspects of the standard version, but it was written in Lithuanian language, which is quite uncommon. Also, it has some specific statements like data collection for academic purposes, and also the alternative link to the bonus resources, as I told you already. So both applications were developed with Java programming language. They used mainly basic functionalities, basic libraries, nothing too sophisticated. And for the data exploitation part, there was a Gmail client used with hard-coded credentials, so no user accounts were used during this experiment. The information about these applications were distributed via an email from the course lecturer's mailbox, but this wasn't a normal letter from the lecturer. It was sent late in the evening with a lot of grammar mistakes, smiles, informal style, missing signature, just to raise some suspicions that this email could be spoofed. If the user decided to visit the website, not the links, but the website, so he will be greeted with this site under maintenance page. And I would like to mention that everything that's connected with the website was free and easy to make, so like a free hosting provider, free domain name, so the attacker could make that without any expenses. And just for this experiment, there were server-side scripts who monitored each and every click in that website just to gather some data. So, and here's the results for Windows application. So as you see, there was a big spike during the first 24 hours. And almost all of the users who passed the test also sent the data to me unknowingly. Also, you see quite a big zero in the last column that says Ola read, so nobody read the document. Quite a similar situation with the Android devices. Also, quite a big activity during the first 24 hours. Also, nobody read the document. Just one interesting thing that if we look at the test passed and data about devices received columns, so that's less than, percentage-wise less than Windows application. So it's really interesting because usually Android devices don't have any additional security programs installed. So in conclusions, users tend to skip EULA, and some big companies take advantage of that legally. Well, more than 60% of data received came within the first 24 hours, so that would be a huge advantage for an attacker who tries some new phishing ways or zero-day exploits. What I mean by limited security solutions functionality is that almost in all cases, if the user decided to use that application, so I got the data from the system. For example, in Windows cases, sometimes there were even the signature by Avast included, that it has checked that email and it found nothing suspicious from it, despite the fact that it's confidential data leaving the system. And well, after a few months, there was an anonymous questionnaire prepared and distributed for these students. So the main question was asked if this experiment changed their perception about the information found online, and almost 80% of the students said that, well, now after they were taught in that way, so they're more carefully about what they found online and double check before installing any application. That's it, thank you. Yes?
Thank you for our presentation. I have two questions. First, how do you think to encourage people to read it more? And the second one, do you read every time?
I will start from the second one. No, I personally don't read it, and I haven't thought about the potential threats that might be hidden inside it before I really got into this problem. But when I started to look at it, I saw that, well, it's quite usual to hit something inside it, and like, well, we're always afraid for something big and scary come and it tries to spy us, but then we let the attacker ourselves in. And for the first part, well, it would be great to have some software solution, like some automatic analyzers who warns you before you install the application that, look, at this particular line, this could be really threatening to you. Also, there could be some like examples to how to reduce the amount of this by software developers, just for them to take an initiative to make this really an agreement for users, not some kind of formal thing that is, well, full of legal terminology and nobody can understand that. Yes?
My question is, how did you, I don't know, not force, but let users to use your application for this?
How?
How many users did you use?
In total, it was around 300, but in total amount of users for which it was distributed was 653. So it's the number of first-year students.
I see. So this was an Android application, is it?
What?
Was it an Android?
It was for Android and Windows. There was both together, like packed. You want to choose Android, you want to choose Windows, no
So
difference.
the users didn't download it, or did you provide them the software?
The software was placed inside that bogus website, and they were given the download links. So they choose which of the application they will download, but there weren't any major differences, just the platform.
Is there a chance to have like a standardized EULA, and then if a company deviates from it, it's obliged to inform users how it is different than the standardized one?
That would be a great idea, but I'm not sure, especially having in mind that, well, it would be great to have an EULA in Lithuanian language at first, but nobody cares about that. They just take something and modifies it a little bit and modify. So I guess nobody writes it from the beginning. It's already some templates taken, but there aren't any standardized version from which they take and modify it. So it would be good.
Who asked me about legislative approach? Go through the EU Parliament, for example, passing legislation of consumer protection type.
That would be good, though I usually think that it's more than recommendation, not obligation for the software developers. No?
Okay, we are in the discussion stage.
Yeah,
We can do after the conference.
if we have some time left at the end, we can discuss the topic in more detail. It's a very interesting topic.
Okay, thank you.
Thank you for your
Thank you.
presentation.
Now, next presenter.
All right. Good afternoon, ladies and gentlemen. My name is Lukas Tasidis from the Faculty of Informatics, a second year. Today I'll be presenting my paper titled Implementation of an FPGA Testbed as an Educational Experiment for Students of Informatics. I'll be going over the problems that led to the implementation, then overview the implementation itself, go over some of the educational gains that it had, and then go into future works, and of course, a conclusion. Firstly, after finishing the first year at university, it became abundantly clear that there was a need to put the theoretical knowledge gained in university into practical use, while still making it relevant in some sense for future work. And so, at the same time, it was also clear that in recent years, machine learning has been an incredibly important field that requires a lot of research. So my mentor, Kazimieras Bogdanas, suggested a project in which I would be able to combine machine learning with easily make use of machine learning and implement a test bed using FPGA boards to practice machine learning in later stages of the project. So essentially, the implementation itself is to create a two-dimensional simulation written fully in hardware, implemented in hardware to make use of parallelism inside an FPGA board. So we are removing all the levels of abstraction, all virtualization, and having it all done purely in hardware. This way we can achieve maximum amount of speeds. So looking at the implementation itself, there are a few primary components. We'll look from the right side to the left side and just overview it. First, we have the maze generation components, which are using a recursive backtracking algorithm to create random mazes. These mazes go to the middle section where we see the level component. Here, a specific random maze is generated and kept, and then we are generating entities on this maze. Now keep in mind that the entities themselves and the maze are simply a two-dimensional array, and everything is stored as simple bits. Everything is physical memory. There is absolutely no virtualization at all. Then we have, to the left side, the specific components for every single entity that is inside the simulation. All of them are making requests to make a move. Yes? Oh, all right. All the entities themselves are making requests to the level components to make a specific move, and they can move either in any of the directions or turn in any of the directions. And then there's also collision checks being made, and they are being given some specific feedback. Here we can see some of the images. To the left side, you can see some of the mazes that can be generated. We can choose any kinds of forms. And then on the right side, you can see the visual aids that every entity gets after they make a move. This would be the input that is given into the components, into specific machine learning algorithms, for example, neural networks, to then use and make a decision based upon and send back to the platform. Now the key here is that while we are able to use hardware to achieve parallelism and make neural networks work extremely fast, we are also able to, by putting the platform itself also in hardware, we're also able to maximize the efficiency of the simulation and then give instantaneous feedback to the neural networks. Now, after the implementation was fully finished, a lot of lessons were learned, specifically in hardware development, state machines, hardware time dependence, signal handling, conveyor systems. All of these were practiced in full, and there wasn't a need for a lot of further education to be able to actually practice and put these concepts into practice, because we had such means like FPGA boards. Now, an important distinction to make is that after the project was finished, it became abundantly clear that there was a problem, in the sense that the platform itself, even as being as simplistic as it is, a simple two-dimensional array simulation, would still take up a lot of space in an FPGA board. Now, the example board used was a cyclone-free board, which cost around $150, and in this board, just the platform itself was taking over 87% of the entire space. So while we were able to implement such a platform relatively easily inside an FPGA board, it does take too much space, and so it's not cost efficient to put the platform and the FPGA and the neural networks in the same FPGA board unless we were using a much more expensive board. So to conclude fully, first of all, for future works, to continue this project and continue to working and experimenting with neural networks, we're now moving the platform outside of the hardware implementation into the software, just purely on a computer, and creating a direct interface with the FPGA board while keeping the neural networks purely just inside the FPGA board. This way, while we're not going to achieve maximum speeds because we're not keeping the platform inside the FPGA board, we'll still be able to fully implement the project and fully experiment with high speeds, high learning rate neural network experiments. So to conclude, we can see that in hardware implementations like this in FPGA boards, they can be extremely fast, but at the same time they're relatively costly. However, such a project is fairly easy to implement, even with little amounts of education, just 1 year at university, and so they have a lot of value and can be very valuable to students to try. Further research will of course be done now in software. So yeah, that would be a conclusion of my presentation. Any questions?
No questions. Questions? Okay, thank you.
Right.
Lucas, it was very good presentation.
Thank you very much.
And now our next presenter, Dambuana, can demonstrate it.
So yeah, hello everyone. Well, I feel a little out of context of this conference because my presentation is not about the results of research. It's about some practices, some good practices, I would say. So my presentation is about fairness. Everyone wants to be fair, no? But the question is, are we? And if the answer is yes, then the next question is, are we? If the answer is no, then the question is how to become fair. So, but let's start from the beginning, yeah? Actually, what is open data? Open data, it's not like we put our data online and everyone can use it, everyone can reach it, and that's all. We can say that our data are open. So actually, putting data on the web is not enough. Openness is associated with fairness. That is, data should follow some principles, some guidelines. That is, open data, in order to be really open, should be findable, accessible, interoperable, and reusable. Now, step by step, about every of these principles. So what does it mean to be fair? Actually, to be findable, first, or discoverable, data and metadata should be richly described to enable attribute-based search. The metadata of a data object should be sufficiently rich that a machine or a human user, upon discovery, can make an informed choice about whether or not it is appropriate to use that data object in the context of their analysis. To be broadly accessible, data and metadata should be retrievable in a variety of formats that are sensible to humans and machines using persistent identifiers. To be interoperable, the description of metadata elements should follow some community guidelines that use an open, well-defined vocabulary. To be reusable, the description of essential, recommended, and optional metadata elements should be machine processable and verifiable. Use should be easy, and data should be citable to sustain data sharing and recognize the value of data. It is worth to note here that these principles are intended to apply actually not only to data in the conventional sense, but also to the algorithms, tools, and workflows that led to that data. In other words, the principles suggest that data resources, tools, vocabularies, and infrastructures should exhibit specific characteristics, norms, and practices in order to assist discovery and reuse by third parties to be considered fair. And what should be noted here also that any combination of these principles actually is desirable and of paramount importance. However, is fair reality? Actually, no. But yet, let's say, actually, we have some really good initiatives, and now I would like to talk about one of them, how FAIR works in practice. I would like to talk about language resources infrastructure, Clarin ERIC. In January of 2015, Lithuania became a full member of Clarin ERIC. Clarin ERIC stands for Common Language Resources and Technology Infrastructure. It is aimed to provide easy and sustainable access to digital language data in written, spoken, video, or multimodal form, and advanced tools to discover, explore, exploit, annotate, analyze, or combine such data sets and tools wherever they are located. Soon, National Consortium, Clarin LT, was founded by three partner universities, Vytautas Magnus University, Kaunas Technology University, and Vilnius University. Actually, the Clarin infrastructure supports the sharing, use, and sustainability of language data and tools through a network federation of centers, language data repositories, service centers, and knowledge centers with a single sign-on access for all members of the academic community in all participating countries. Tools and data from different centers are interoperable so that data collections can be combined and tools from different sources can be chained to perform complex operations to support researchers in their work. Principal scheme you can see here, principal scheme of the Clarin functionality. And I should say that with joining this infrastructure, Lithuanian resources and services now are available to the various research communities at large, and Lithuania as a member of this infrastructure gained practical benefits. Now Lithuanian language data and tools are available not only through specific websites but also through this infrastructure. And now Lithuania has its repository, Clarin repository, which contained 5 resources at this time now. Here you can see how FAIR data repository looks like. And actually, data in Clarin LT repository are made available under licenses attached to the resources. But in case there is no license, data is made freely available for access, printing, and download, whatever, for the purposes of non-commercial research or private studies. The repository is like a library for linguistic data and tools to search for data and tools and easily download them, deposit the data, and be sure it is safely stored. Everyone can find it, use it, and correctly cite it. This supports the findable part of FAIR principles. So actually, Lithuanian language resources and tools can now be reached not only, as I said, via special website, but also via infrastructure. The repository integrates full machine-readable, highly curated data elements. The latter obviously also with FAIR metadata attached. It accepts a wide range of data types in wide variety. Formats generally do not attempt to integrate or harmonize the deposited data and place few restrictions or, let's say, requirements on the descriptors of the data deposition. And if we are talking about infrastructure, then I would shortly talk about, let's say, more global infrastructure. It's new initiatives by European Commission, European Open Science Cloud. The European Commission suggested European Cloud Initiative, which set an ambitious vision for the European Open Science Cloud and committed to make this vision a reality by 2020. European Open Science Cloud is a data infrastructure of commons as an ecosystem of infrastructures with an enabled automation and data. It aims to accelerate and support the current transition to more effective open science and open innovation in the digital single market. Actually, the European Open Science Cloud is indeed a European infrastructure, but it should be globally interoperable and accessible, as suggest the authors of this initiative. It should be enabled trusted access to services, systems, and reuse of shared scientific data across disciplinary, social, and geographical borders. In other words, it's about a federated environment for scientific data sharing and reuse based on existing and emerging elements in the member states, with lightweight international guidance and governance and a large degree of freedom regarding practical implementation. The European Open Science Cloud includes the required human expertise, resources, standards, best practices, as well as the underpinning technical infrastructures. So here you can see the basic opportunities offered by this initiative. So an important aspect of the European Open Science Cloud is systematic and professional data management and long-term stewardship of scientific data sets and services in Europe and globally. However, as said by authors of this initiative, stewardship is not a goal in itself. So, in the end, what I can say that actually, the coolest thing to do with our data will be thought of by someone else, not by ourselves. I should. So that's why we should open, and that's why we should be fair. So thank you.
We are a little bit short on time, so
Okay.
no questions this time. Thank you for your
Thank you.
participation.
Thank you.
Thanks for you. Okay, and now next presenter.
Okay. Hello everyone. I'm Cenkar from Kaunas, Lithuania. Today I'm going to talk about after developing many games with with Kinect for Xbox and for computer, for PC, for Windows. I came up with a point that I had to compare two devices using my own, developing my own software. So the motivation was for me to do my research is to growing demand for natural user interfaces because today from Oculus Rift to computer games, from computer games to scientific approaches, they all uses user interfaces, and some uses leap motion and some uses different devices for that. Another one is usability issues prevent from using natural user interfaces in wider range of applications. It means that many devices come up with different gesture types, and those gesture types sometimes can make usability issues for the users. And another one is a study of common gesture usability for widespread natural user interfaces. So this is the actually topic of my research. So when I describe the common gestures, there are three commonly used hand gestures. Common gestures are legalized in Kinect's 2012 documentation paper. So those are push to select when the motion is a push select, and wait to select when you wait on a specific user interface, and the grab to select when you make a grab motion to choose the specific interface element. There are a couple of many relevant works, but I found these three. If you want to talk about all, we don't have time. Maybe I will skip this one. This is the testing framework that my software shares. I use square formation for the 1080p screen size and for resolution, and I keep this formation to be able to test two devices in same circumstances. The experiment made with, of course, two devices, and the experiment conditions were arranged to account for optimal usage recommendations of the Kinect device, as I mentioned before. We focused on Kinect and then changed it to also compare it with the leap motion. What I wanted to say is when the user makes a specific movement to select the user interface element, my software makes the user ready for the next experiment to calculate optimal execution time. So the methodology I used, unfortunately, I had only 10. I could only accomplish in 9 attendees since I had a deadline for finishing my system. Of course, this number will increase. I did it, but the system worked very well. The testing was made on 3 hand gestures, as I said. And the task is to select randomly highlighted buttons. So each button you select, you get one screen, says 5 seconds for the next button, and those buttons are highlighted randomly. So the user don't expect each time the same button will be highlighted in sequence. Each button click lets users to get ready for next button, as I said. And those are my results. For the wait to select Kinect and wait to select leap motion, we can see that leap motion in all button locations. This is top left, up, top right. Top left is the button number 1. So I want to mention this way, so it's better to go top number 1, which button. So it's top left, up position, top right, left position, and middle. So you can see the all results here for the wait to select motion. This is for grab to select result. As you can see, Leap motion is far better than in terms of execution time from the Kinect. And the push to select also leap motion way better, way faster. Not better maybe, but faster. If I want to conclude my research paper, leap motion device gives the best result at all locations for interacting on UE between all gestures in terms of execution time. I want to quote this. We see that users can make faster executions if the formation is in the middle, up, center, and the bottom of the screen. If the menu is centralized in this direction, in the middle direction. And the results show us that the grab to select gesture for leap motion performs the fastest in terms of execution time. And it is also observed that the button corner size for the placement of buttons reduces interaction effectiveness in all gesture types. And I want to add this one more thing. If the user is right-handed or the left-handed, if the button is placed in the right-hand side, right bottom-hand side, and the user is left-handed, for this particular tester, it takes more time to grab the one that is in his opposite side of the hand. So this is also one conclusion that I forgot to mention here. And the last one is this depends on the Kinect tools and leap motion's detectable range and correct user movements also. It also changes the execution time. What I'm planning to do in the future work, I'm trying to make custom gestures. This is study more gestures means the custom gestures, not the main gestures, but more like swipe or hold to swipe gestures to implement those gesture types. And I'm also planning to expand testing range, not only for execution time, for an individual, but also for accuracy rate. It means that what each individual gesture type error for each individual tester. So how many misclicks or how many correct clicks one individual does. Thank you for your attention.
Any questions? Questions? No questions. So thank you for participation. And our next presenter, Rainer Schüler, please.
So hello, I'm Dina, and today I'm going to talk about evaluation of business process management systems. First of all, in organizations there are different kind of process. For example, how we manufacture tools or how we manage projects and so on. So business process modeling helps organizations to graphically define that processes to identify problematic areas or potential risks. So business process management systems let us to model that business process, to manage it, to execute it, even simulate it and so on. So for organizations, it's hard to choose the right business process management system because there is no defined criteria for doing that. What's more, choosing of BPMS is quite subjective since organizations don't have such a lot of resources for doing that. Currently, I'm working on my final degree project where I'm creating the method how to manage projects where you create systems by using business process management systems. And in this method, there is 4 phases, and at the beginning of the second phase, we have to choose the right business process management system. To do that, we need guidelines how to do that, so we created a framework of evaluating business process management systems. We have a list of criterion, and we classified them into 6 groups, which I talk a little bit later. And each criteria has its weight, which shows the importance, and the criterion can be assessed into 4-point scale from 0 to 3, where 3 is if system fully meets the criterion. So first of all, we have business process modeling, and what do we need from those business process management systems? First of all, we want to model our process, so we need functionality for process modeling. Also, we'd like to model our data, which we want to keep about, for example, our clients or suppliers, and we need business rules, which defines how decisions are made in our process. What's more, we need a functionality for process translation into executable one, and we need to create forms because we need users need to put information in our system. What's more, we need a possibility to assign roles to these users. Of course, we want a function for user information. We want to inform them about change and about problems via email or via messages. While executing our business process, we need to monitor them to see any bottlenecks or problems, and we need to control. Maybe we would like to change our business process while it's being executed. Also, if we have process and we have a new information system, we don't like to do it the real data to test that new system. So we can simulate process by using test data and to see if this business process management system is working for us or not. We also evaluated some common features. For example, if we can find training materials about a business process management system. Our suggested framework is like recommendations for you how to choose the right system, and it is quite flexible because you can change weights or you can choose evaluation scale. Maybe you don't like a scale from 0 to 3, maybe you like from 1 to 10, so you can change it. You can add more criteria or to delete if you don't need any functionality, and you can change the order of the evaluation. So to test our framework, we did a case study where we compared these four open source business process management systems. So this is the part of it. There is a monitoring and control aspect. There is 2 criterion, and as you can see, Camunda got 6 points, and it's a maximum for these 2 criterion. So after we tried these systems, after we made deep analysis, we identified that the best match for our selected criterion is the Camunda system. And now I'm using this system in my final degree project where I'm testing it and experimenting the system. So at the beginning, I would like to say that our suggested framework consists of selected criterion and instructions how to evaluate these criterion. And as I mentioned before, the framework is really flexible. You can change something like criterion, and this framework will be used in further researchers of the university academic department and my final degree project. Thank you for attention.
Any questions? No questions, so thank you for your participation. Thank you very much.
Thank you.
So next presenter, Ivana Vikaite. You are welcome.
So, hello everyone, I am Ilona Veitaitė and from Vilnius University, Kaunas faculty. I will present my supervisor's Professor Audrius Lopata paper about enterprise knowledge-based UML timing model generation process. Nowadays it is quite difficult, and one of the main goals of organizations is to align business and IT, because information technologies take very important place and play very important role in every organization. So it is very important to make them aligned, and everyone knows that business depends on IT, and IT of course is dependent on business. So one of main ideas of our research is to use enterprise model. Enterprise model, which we are analyzing, is already used in some organizations, and I'm going to we are going with our colleagues a little bit deeper. We are trying to use this enterprise model to generate UML model diagrams, UML models, because UML is quite popular and used over the world, and it is quite understandable and for IT people and for business people. So here you can see the principal scheme of business and IT alignment, when one of the components is knowledge storage of case tool, which is based on enterprise model and enterprise meta model. This is field where we are making our research, so I will try to explain more about it. And as you saw in previous slide, one of the key component is the knowledge storage, where is enterprise model, and it is knowledge-based subsystem. So here is the connection between enterprise model and enterprise meta model in the system. So as you can see, the user of the system is analyst, and he is taking information, he is querying for information into the system. And here we can see how the system works inside case tool, where the data is stored, and this data is already validated and verified in enterprise meta model. So the main idea is that this data is already validated and can be trustfully used in future process. Also, the idea of using enterprise model is to help the designing and information system engineering process. So we looked for meta-object facility architecture, where main idea is that meta model is a base for all the process, and there are four levels: third, second, first, and zero. And as you can see, everything begins from meta model, then meta model, and last one is data, is modeled systems. So here we saw the opportunity to use our enterprise model like an additional layer of model architecture. So it is between meta model and meta model, so we can be assured that the information stored in this model is already verified and validated. So to explain more, I would like to show you the enterprise model described as Maltsev algebra, where M1 is enterprise model as algebra system, K is elements of this system, and R is relationships. So to be exact, to be concrete with the enterprise model, here we can see all the elements from K1 to K21. as you can see. And here we can find the process, the function, the actor, event, goal, material flows, information flows, all the information we need to know in business organization. At the same as of algebra, here we can see enterprise meta model in these, according to the description before. And according to this models of algebra, we tried to show UML timing model. Also, we used the elements of time model, relationships, and so on. And here we can look to described timing model composition according to timing model. And this is a scheme of timing model based on models of algebra. And why I'm showing this to you, the main idea is here to show you the relationship or intersection between enterprise model and UML timing model. Here we can see that related elements is described as phi1 and 2 phi6, and this is one of the parts which shows that we can generate UML timing model elements from enterprise model. Here you can see more obvious that actor from enterprise model can be the main base for the generating, and in UML timing model this will be a lifeline. And for example, state or condition timeline in timing model is generated from information flow in enterprise model. As I think you know, UML is quite widely used and there are a lot of models, and we decided to generate dynamic part of these diagrams of these models, and this case is just timing model, but we also did it with activity diagram, use case diagram, interaction overview, state machine, and sequence diagram. And in every case we saw that it is possible to generate all these diagram elements from enterprise model, maybe a little bit modified, but it is possible to do. And back to the UML timing model, here we can see the project lifecycle stages, and this is certain example of timing model. And for example, if we go back and see that time constraint from timing model is generated from business rules in enterprise model. So in this slide we can see that time constraint is showed here in weeks element. So as main idea of this paper is to present the possibility to generate UML timing model from enterprise model. As I mentioned before, we did it with other UML models, so it is possible to do. And the main idea why we're doing that, we are trying to make easier the design phase of information system engineering process to creating software process, and to be assured that information safety in enterprise model and used in UML models is trustful, and that's why we can escape from the mistakes, from the additional funds for making and to correcting done mistakes. So in this case we are looking forward to try the generation prototype and to show more experiments where the this generation process helps in design stage. So thank you, and questions?
Any questions? Questions, Thomas? Okay, no questions. Thank you very much.
Thank you.
For your
It's nice to be here.
You're always welcome.
Thank you.
Okay, our next presenter. Go to the
Hello. My name is Tautas Petkus. Sorry for my slides being Lithuanian, but I'll try to speak in English. I did research about the brain computing device appliance for a game and its quality and its usability. I presented this research with a colleague Carlos, but he could not be present here right now. So what is the goal of this research? We have the devices called electroencephalographs, in short EEG devices. These devices measure users' brain waves, which are later on can be used to determine the diseases and maybe found any possible solutions to find the cure for the person. Also, these devices can be used for monitoring the athlete's mental condition. And there are some debates and questions whether these devices can be used actively when the user is performing some activity at the moment. The problem is that these devices are strictly dependent on the quality of the data, whether the user clenches his muscles. Even blinking or jaw clenching can cause serious penalties for that data accuracy. And it's wondering whether it's possible to use these devices in some active fields. What we're trying to achieve is to pick a certain group of people which can then be used to measure the quality of this device integration into the video game, which is dedicated for yoga. We have prepared a prototype where user performs some certain yoga activities in front of the monitor, and it tracks its movements. And also EEG device, which is displayed here, called Muse, also evaluates the user's mental condition, his relaxation, and gives the feedback whether the user is relaxed or not. Also, we were determining the user's satisfactory by giving him questionnaire and measuring his time spent on the product. What our the device, the system looks like. We have connected to motion tracking device, which tracks the user's movements and evaluates whether the user is performing yoga correctly or not, and Muse EEG device, which tracks the user's mental state before the exercise and during the exercise to compare how the user performed in static condition and how he performed in active condition. Also, Muse EEG device provides the API for tracking the user's mental parameters like alpha, beta, brainwave frequencies, and also evaluated relaxation coefficient. What we are also doing to evaluate the user's satisfactory is using a music metric system, which determines the conditions of the performed test and also measures the usability of the system by evaluating how much time the user has spent in productivity and how much time he spent by doing some unnecessary stuff like looking for help, configuring his hardware, and so on. The devices which were used are Muse and connected devices. The range of the people were participating was from 20 to 35 years old. And what we're trying to do is turning on the devices, doing the mini game with the EEG devices before the workout, and during workout doing exercises, performing like muscle clenches, and also trying to maintain the stable mental condition. the environment where the users were participating in was a big open room with with good floor. Also, we were giving the users a questionnaire called IVUS, which gives 10 questions for the people to evaluate their satisfactory with the system. These questions later on are turned into the results, which evaluate the user's satisfactory from 0 to 100%. Also, we were recording the whole mental activity before the workout and during workout to compare these two data arrays. So we took 5 people which took the test and evaluated the system. They did a 2-minute mini game which in stationary position, where they're just trying to relax and give the best relaxation feel by themselves. As you can see in the illustration, it's the snapshot of the mini game we are trying to do. At the current time, they were trying to relax, and the game we're telling them how much their relaxation changed. After this mini game, they were doing yoga exercises for 5 minutes, where also their motions were tracked and their mental state was recorded. And after the game, we were given 10 questions where they answered and given their feedback. After the whole research, we evaluated the data we received. We calculated how much time they have spent with the whole game, and how much time they needed to prepare for the training, how much time they needed for users' help to configure the hardware. We noticed that many of the participants didn't know how to use the Muse EEG device. They didn't know how to put on it properly, how to configure it, and most of the times they needed researchers' help for figuring it out and putting it correctly so that data could be received best. Also, by IVUS questionnaire, we found out that the average satisfactory by the system reaches 82%, which is by the metrics is average. To consider the system good, it needs to reach over 90%. The questions which were given in the questionnaire were like, how often would you like to use the system? Was the accuracy of the data good? Was it comfortable to use? And many of the participants were struggling and didn't think that they would like to use the system too often because the complexity of the EEG device. Also, we calculated the averages of the EEG devices, which gave users relaxation coefficient. In blue, you can see how much relaxation they reached before the workout, and in orange, how much relaxation the device shown during the workout. As the paradox, it's the relaxation should reach should be lower before the workout due to the stress the user receives during the workout and because of the muscle clenches. And we think that this result comes due to the muscle clenches and data loss during the workout, since the EEG devices depend a lot for the stability of the device, for being stable. And the conclusions by IVUS metrics, the device EEG devices like Muse are considered average by the users. They don't think that it suits their needs too much, and the use of these devices are not that great right now for the active activities like yoga and other physical activities. So for that, they need to be improved, maybe be stationary and just attach with some harder means rather than just putting the device on. So that's it. Any questions?
Any questions? Okay, I have one question. It's about your last remark that you must attach it or fix very well.
Yes.
So did you consider shaving the head of the subjects just to ensure that it attaches?
Well, the device itself is placed on the forehead of the user, so it's basically just attached on the plain skin rather than just on the hair.
So maybe just the location was not exactly right for this type of.
Well, the device itself is designed to be placed on the forehead. Some of the other devices which have more sensors, they are placed all around the users. The EG devices come in various shapes and forms, and we chose the one which is most widely available in the wide market rather than the scientific field.
Okay. Any questions more? No? So thank you for your presentation.
Thank you.
Okay, our next presenter is from Latvia.
Hello, I'm Alexei Josefs, and I'll talk about programming assignment verification, testing, and plagiarism detection approaches, especially in courses like discrete math, artificial intelligence, and similar. Why I have started this research? Because being a lecturer myself, at some point I have started to notice that my workload has significantly increased over the last 3 years. And here I have mentioned reasons why this could happen. And all of this motivated me to start the research on how to reduce my workload by automating some parts of my work. Currently, there are two the most used approaches how to verify programming assessments. There are either checked by hand or there are specialized portal integration. Modern universities, of course, have some kind of Moodle or Blackboard portals where students can upload their works, and these works can later be checked by lecturer or by professors. And these portals can lower human factor influence by providing additional verification features or some additional plugins to assess this issue. But of course, there are no concrete solution at this moment for example, Moodle or for any other integration, even custom-made. What can be automated in this case, in case of either verification by hand or by uploading this stuff to some portal? At least there could be three different approaches. First of all, we can provide pre-verification checks, so those checks are done before we actually trying to run this code, actually try to verify the assessment. So we can check the code for sanity, whether it is code or something else. We can check if this code will compile without actual running, and we can check whether this code is following appropriate code style, which was given by professor, for example. After we concluded that our work, our assessment is can be compiled, we can start actual testing. So actual testing can be done using actual assessment test runs. We can check whether the input data is actually verified. We can check some border cases, and we can measure performance. maybe it's imperative to have high performance during some mathematical problem solving, for example. And the third one is anti-plagiarism testing, because mostly people can just copy-paste assessment solutions from other students or from internet and try to pretend that this work is unique. There are additional metrics how we can define whether our integration or automation approaches are good or bad. Here I have created 5 metrics to check whether it's appropriate for implementation or not. And we have checked 2 mostly used implementations, where one is for custom or by hand verification, and second is, for example, as Moodle plugin. So there are additional, like I said, plugins which can reduce teacher workload. And that the third approach, which is combined with continuous integration CVS integration, is our proposed solution, where we can create a complete scheme where all the elements are working together to automate the most possible parts of this system. Before that, I would like to talk a little bit about plagiarism detection. Well, in case of programming code, it's very hard to detect actual plagiarism, because code can be the code can be very different, but they would create the same result. So to detect this plagiarism, there are 2 at least common approaches how to do that. One is to use abstract syntax tree comparison for the 2 different codes. So we can remove all kind of comments, new lines, and so on, and we can extract code execution, let's say code execution plan, and we can create a graph from that plan, and we can compare execution graphs, so we can check whether they are similar or the same, or they have some difference. Of course, that can be appropriate solution only for middle or maybe large examples, because if the request from professor side was to create just a simple function, it will be useless, because at most mostly, let's say, the solutions will be very similar or even the same. And the second is cyclomatic complexity evaluation, where we can create similar to abstract syntax tree representation of our code, so we can actually extract some metadata about how this code was not created, but what it will contain when we run, for example, tests, or how it was designed from the coder or student perspective. Well, the complete system, how it should work in our proposal is the student is after he's created his assessment, he will upload his code, actually push this assessment code to Git, and after that, either by cron or some scheduler, or using push commit hook, the Git provides this code to CI agents, which in turn will try to create all this testing environment, because there are actual possible vulnerabilities when teachers are trying to compile and run student code on their machines, and if code are trying to do some malicious things, this code will be actually executed on the computers, and that's not, it's not good. So we propose to use isolated environments, for example Docker or virtual machines. After this code is done, this code testing is done, these machines or containers can be disposed, and the space will not be used as much as they could be during regular runs. So in case this CI agent found some problems with the code, or for example tester failed or something like that, he will be able to reach the student with the appropriate information by means of email or by sending private message in Moodle. Later on, additional information retrieval system can create plagiarism checks and run against published code, and if all is going fine, the submission status will be updated in Moodle, and the report of course will be passed to the student. So the main conclusion that it is possible to improve current approaches to code and programming assessment verification. It is possible to automate a lot of things. It is possible to create the complete system which can be used with the existing portals like Moodle and so on. And our goal is to actually create this on-site solution which can be used for a wide variety of these assessments. Well, that's actually all it. Any questions?
Any questions? You have one question. How does your approach deal with code obfuscation and all that? Angle code.
Yeah. Actually, code obfuscation will not pass code quality, or let's say code style checks. So in case of dramatic failure on this case, so for example, we can measure, for example, by points how many rules have applied or how many is not. And if, for example, we can see that none of the rules have applied, so probably the teacher or professor can decide why that is so. Maybe it's some testing failure from the system side, or it's actually obfuscation from the student side.
Okay. Thank you very much.
Okay.
Hello, my name is Edgar. Sorry, presentation is in Lithuanian language. I'll try to cover it in English. So, my research topic is basically service-oriented architecture evaluation based on maintainability index. Here is some short topic what I will try to cover in this presentation. Basically, what is the purpose of this research, then the definition of the SOA, then what is the maintainability index. Then I will try to explain and cover the experimental scenario, the methodology of it. Then I will try to explain what was the results, and at the end I will cover the conclusions. So the purpose of this research was basically to figure out and define how maintainability index is changing for SOA-based applications using different architecture layouts. So basically, having different type of architecture design to measure and see how maintainability of the whole system is changing. The purpose of experiment was to figure out what kind of things, what kind of metrics is making that impact of dropping or raising of that maintainability of system. So W3C consortium describes SOA as a set of components which can be invoked and which has interfaces, interface descriptions which are basically published and can be used by other systems. So basically you have a set of components loosely coupled and they can be reached through their interface descriptions through any standard communication protocols. Other authors and researchers described it as a development paradigm, which is basically says that you can distribute your program, your software algorithm into different services, which are loosely coupled, stateless, and they can basically use other services in order to solve some kind of algorithm or solution. It's a common case that in SOA based application you will find also an n-tier architecture style, which is basically allows you to distribute system logic into distribute system process into different layers. So you can have, most cases you will find out that it has 3 tiers, where you have presentation tier, which is basically responsible, well, in some cases for displaying and providing some kind of interface to users, but a little bit more enterprise applications, you will find out that it has endpoints for distributing metadata that's need to be that's define how to communicate with the middle tier, which is the business layer, which describes the whole logic of the platform. And in the end, we have the repository tier, where we have the services which are, and the processes which are responsible for the data management. Now, maintainability index is basically a code metric which is used to measure how the system, how the program is maintainable and how easily it can be supported. There is a lot of different topics and a lot of discussion what kind of ranges to use it and what kind of range to have. At this table you see some kind of ranges provided by Microsoft, but other tools which are measuring also maintainability index, they tend to say and choose a little bit different ranges. The reason is basically that how they measure maintainability is a little bit different. They use different metrics, and one of it is health seed volume. So in this case, in Microsoft tend to use the health seed volume. In other cases, they use health seed effort and etc. Also worth to mention that maintainability is measured using three. Basically, it depends on 3 metrics. It's health seed volume, McCabe cyclomatic complexity, and also line of code. Now, during the experiment, we had actually 4 scenarios. In the first one, we see that we have a system structure, system architecture, which we have basically one endpoint, which is responsible only to provide the interface to main service, MS. You can see it in the middle tier. Then you have 10 repositories. Basically, all of them are simply responsible only for storing information into some kind of storage device and etc. In second scenario, you can see that we have a little bit distribution. We have few extra services like S1, S2, S3, which is basically taking over some of the responsibilities of main service and basically providing some kind of logic for the main service to complete the main algorithm of main service, which is not so complicated. It's just simply data inserts and it to the database, and that's it. The remaining scenarios is simply just differs only by having different layouts and different connections with the services. Now, experiment has its steps. So at during the first experiment step, you simply have one step where you have endpoint, we have main service, and you have a single connection with one repository. As you can see, it's marked in red. Then you make a measurement. Then you connect more services like those S1 and R2, which are colored in green. So then you can you make those connections while you complete the whole algorithm of the main service. Each time you connect the new services, you make a measurement, and at the end you can see, at this chart you can see how maintainability index is changing for the first scenario and for the second. You can see that having first scenario, the maintainability is really start to decrease faster. Well, it doesn't reach its limits because the whole architecture is pretty simple and pretty small. But you can see how it's going. At the second scenario, we see a little bit slower decreasement. So we can see some kind of perspective that it's quite better to use a second approach. Other remaining scenarios basically are the same. The results are the same as the second one because you just simply switching the services, how they are consumed. You're not applying any new services, so it doesn't affect the whole maintainability of the whole platform. Because during calculation you are using averages of all metrics. Now, after experiment, the correlation coefficients. The correlation was done, and some values was measured, like to see how other metrics are impacting the maintainability. Like, for example, McCabe cyclomatic complexity and lines of code, you can see it has negative values, so it means that when those values are dropping, the maintainability of system is rising. Also, interesting thing is that health state volume metric, we see a positive value. That means that if it's rising, the maintainability index is also rising. Conclusions. So, as I just talked before, when we have a cyclomatic complexity and lines of code increasing, we can say that and see that the maintainability of the platform is rising. And when we have health state volume rising, we also can say that maintainability of system is rising. It's an interesting thing, but also worth to mention that if you distribute those services not in the correct way, and there is a lot of development approaches how to do it in the correct way, but if you won't stick to that, you will really have a low maintainability index. And if you do apply those designs, you will really have good maintainable system. Also worth to mention that you need to distribute those services really in a good way. In that case, you will have health state volume raised, but other metrics will be also affected. So it's really important to mention that it doesn't mean that you only by raising health state volume, the whole maintainability will raise at the same time. You need to take into account and think about other metrics like cyclomatic complexity, which is the most basically important metric, and take all those things into account, and then make a structure, make an architecture for your platform. That's why this service-oriented architecture is basically used for the enterprise applications, because in a smaller scale applications, it doesn't really make a really big impact on maintainability, because you're just building huge volume. Your application volume is rising, but the logic of your application is really simple, so there is no need for that. And what I suggest to do personally after research, I also have some practices with this kind of projects. I really intend to offer to stick and isolate your services and keep them clean. Try to keep cyclomatic complexity as much as low, and distribute those logic into separate services. That's it. Questions?
Any questions? Questions? No questions. So Thank you very much for your presentation.
Thank you.
And next.
I am going to represent the research on human activity recognition based on image classification methods. Recently, human activity recognition problem has become a significant matter of research. In most of the cases, it has a very explicit practical use. It is an integrated part of human behavior-based systems. One of the key features of smart system technology's task for human activity recognition is enabling to identify the current indoor activity. Fully autonomous and barely noticeable assisting systems are appropriate for daily use. So, practical solutions rely on the combination of video monitoring devices and image classification methods. Various techniques are applied for human activity recognition, but the major challenge is to evaluate the reliability of selected technologies. In most of the cases, possible technical solutions rely on wearable sensors, accelerometers and gyroscopes, depth or thermal imaging cameras, and also on video monitoring devices and image classification methods. There are some popular categories of human activities. For example, static postures and dynamic motions, sport activities such as jumping, walking, or running, and hand motions, waving or clapping. We need to identify what kind of categories are used in target areas, which are unhealthy habits prevention, anomalous behavior detection, health monitoring equipment, and human behavior-based systems, smart home solutions. So we have selected 5 categories of human activities. The first category represents communication, the second one sleeping or having rest, the category number 3 represents empty spaces or temporary human being, the category number 4 represents working with computer, reading, writing or studying, and the category number 5 represents eating or drinking. Also, we have selected 4 different methods for the experiments. 3 different convolutional neural network architectures, AlexNet, Café Reference, and VGG. Also, back of futures support vector machine and k-nearest neighbors. Using the same set of images representing human daily life activities, these methods have been applied for image classification into 5 categories. The image datasets containing more than 500 images for each category of human activity have been collected. Each dataset has been split into a training set, which contains 400 images for each category, and a test set, which contains more than 100 images for each category. As the results show, support vector machine and k-nearest neighbors are not appropriate methods for such complicated tasks. Back of futures has shown average results. All CNN architectures have shown very similar high accuracy results. It is important to compare not only technologies, but the categories too. The results have shown that activities of category number 3, which represents temporary human being, determine the best results of classification for all methods except nearest neighbors. The recognition of activities belonging to category number 2, which represents sleeping or having rest, category number 4, which represents working with computer, reading, writing, or studying, and category number 5, which represents eating or drinking, are the most complicated and provides the worst results of classification. To conclude with, the application of different CNN architectures have shown very similar high accuracy results, although AlexNet has reached more than 90% average accuracy, which indicates the best score of all applied methods. Next studies are needed to analyze the combinations of discussed and new techniques for the solution of image-based human activity classification problem. Thank you for your attention.
Any questions? Questions? Martina?
Okay, maybe I have one. What kind of features of images did you use for classification? That is, for example, where the features used simply the values of pixels, or, for example, some sort of means variances, responses to filters.
Yes, the filters were used.
Ah, okay.
Any more questions? No more questions. I'd like to thank you for your excellent presentation, and also your paper is the best paper of the conference, so please your certificate, and I wish you to continue as good as you did your presentation here. So thank you very much.
So hello, I'm Ieva Bumbuliene, and I will present our team work on topic an overview of Lithuanian Internet Media Engram corpus. So firstly, why do we need corpora? Corpora is widely used in computer linguistics tasks, and Lithuanian language is under-resourced from the perspective of engram corpora. What is engram? We can define engram in this context as a sequence of words, of n words. And in this example, we can take an n-size window and shift it by one word until we reach the end of a sentence. And from this example, the engram where n is 2 would be lorem ipsum, ipsum dolor, and etc. Engrams are widely used in many natural language processing tasks, like spelling correction, speech recognition, text tagging, statistical machine translation, and other tasks. Our team constructed initial corpus from Delphi.lt news portal. It was constructed and crawled by a web crawler, and it covered time period from 2014 March to 2016 November inclusively, and covered categories business, people, news, life, sport, and other that can be seen in the picture. The corpora was saved to a database, and overall it was 72 million words, 190,000 articles and also contained meta information. This meta information is URL, data, date, category, source, author, and also article itself. Firstly, the corpus was preprocessed and the document symbols analysis was done. So it was realized that there are letters and numbers, and not only Lithuanian letters, but also other languages like Greek, Japanese, and Russian, and other symbols. But not only punctuation marks, but also some symbols like euros, pounds, degrees, and other ones. And there was a problem that some symbols they're encoded differently. So there that was different kind and with different encodings. After that, a sentence splitting was done at Computational Center of Linguistics at Vytautas Magnus University. And the TXT files firstly was separated by paragraphs, and after conversion they were separated by sentences, every sentence in new line. So first, in engram generation process, it is necessary to make text clear and remove all punctuation marks and other symbols. So the first sentence is split by spaces and lowercase, then the words that contain only one symbol that are not letter and not digit are thrown away. After that, some patterns are searched, like float numbers, like here, and URLs, emails, and other predefined patterns. Also, where there are some words that weren't split by spaces, so it was necessary to split by other symbols, which were analyzed before. So when we have a clear sentence, we can generate engrams. 4 collections of engrams were generated: unigrams, bigrams, trigrams, and 4grams. And after generating it, the frequencies of engrams were calculated. So after all this process, we have 4 collections of engrams, in total 72 million unigrams, 65 million bigrams, 62 million trigrams, and 57 million tetragrams. The unique percent of engrams varies dependently on n size. The bigger n, the bigger percent of unique engrams. And the same is with engrams with frequency of 1. The bigger n, the bigger percent of engrams with frequency of 1. There's a different situation with maximum frequency of 1 engram. This means the most popular engram in corpus. So when the n is bigger, the maximum frequency of 1 engram is smaller. So to conclude, the initial corpora was collected from Lithuanian news portal Delfi.lt, and 4 engrams collections were generated for every sentence according to specific rules. Also, statistics were calculated for this newly constructed internet media engram corpora, and this engram corpora is designed to contribute to publicly available, ready-to-use lexical resources for various NLP tasks, and it will be soon available for all users. Any questions? Yes? Because it is one of the most popular news portal, and in many portals there are a lot of same articles that are from different sources like BNS, ELTA, Gizmeto, and others. So it covered not only the Delphi as a source, but Delphi was a source for all these articles that are also from other sources.
I also when people took comments from Delphi and constructed an artificial idiot. Do you know something about this project?
Yes, I heard it, but I don't know details.
So thank you very much for your presentation. Thank you.
So hello, my name is Marius Plutinavičius. I'm from Vilnius University. My topic is dimensionality reduction for financial data visualization. So keywords: financial data, big data visualization. Some introduction. Personally, I work mostly with financial markets. My research area is financial markets efficiency. So mostly I investigate the factors who affects this efficiency, and I have such problems with big data because there are a lot of factors, a lot of amounts of data. My colleagues, they work especially with big data methods, especially with visualization methods, dimensionality reduction methods. So we try to work together, and I try to help them to test their methods. What we work, there are a lot of methods, there are a lot of different methods, so we want to try to make new and better who can deal with problems that we have today. So that first of all we need methods, second we need environments who can just manage with such amount of data. So the goal of this particular research was to try how we can visualize the financial data. Especially it was data of stocks from Nasdaq Stock Exchange. So we tried different ways how to do that in the best way. First of all, what we did, we made a review of different methods, the most popular methods like principal component analysis, random projection, MDS, so they are well known. We try how we can improve them. So if just briefly look through the literature, we can find that yes, we differ in their speed, in their accuracy, but mostly we can find people just look to the speed or accuracy. There is some lack for the reviews that would include both of these factors. So we try these methods with the different data and look for both these factors, try to find which are the best. And our idea is, if we have just big amount of data, first of all, we can use the fasted methods. And later, when we reduce the amount, perhaps we don't need such more speed, but we need more accuracy. So we could just automatically find which particular method is the best for which that situation. In this case, what we did, we used two methods, random projection at first, and then MDS after that. And we used MPI technology to use parallel computing to increase the speed. And the results we got. So first of all, the data. We had 1,400 companies, and we had 45 parameters that describe them. So we wanted, that. And the problem is that the data can look not so big, but when you get the updates each millisecond, so you have a problem with bounds. So we tried how we can visualize such data. First of all, there are some results of performance. So we took the best environment, the best number of cores that could just give the best results of speed. And the results. We had several hypotheses. First of all, we wanted to try, there are such parameter as analyst recommendation. So you could think that if we tell you should buy this one, or you should do not buy this one, so we should separate. But when we tried these methods, we couldn't find any difference between these two clusters, because we really separate this data and you can see that it just overlaps. So we could think that that's the problem of methods that we don't work, or that may be a problem with analysts that we could just can't separate it. So okay, we tried different views and we just always overlapped. So okay, we thought perhaps that's a problem of methods. But when we raised our hypothesis, we took more components, more real parameters. We created that we can really tell that's a good stock and that's the bad stock. Okay, so we made two clusters, and of course the third that's for the rest of companies. And when we tried this, you can see that it separated not well, but much better than in the previous way. So we can say that yes, from the correct amount of parameters, we can really analyze the data. We can really see the differences. We can separate, but this depends on the type of data. So we really need to find the best components that describe that set of data and the best methods for that. So so what we are doing now, so we are testing that methods with different kind of data from different sources, and just looking if we could find the rules, what could be just applied to automatically select the best methods in particular situation. So thanks for listening.
Any questions? No? No questions about stocks? I have one question. How did you separate with good stocks, bad stocks?
First case was managed just as I said by recommendation, and second one is just like a methodology. When you have parameters, you can say if
it's like more like fuzzy, not
yeah, it's more fuzzy and it's more expert. But it's the common rules when you can just evaluate.
How many experts you?
Okay, 3, 4, but that's the common rules that you can just find in the, in daily life, how we evaluate. So just very simple and general used.
Did you use
So hello, my name is Vilius, and together with Mantas Lukaševičius, I was working on clustering Lithuanian news articles. So as you may know, there are many news articles coming every day from different sources, and we ask ourselves if we would like to create a new news article aggregator, how we should do the clustering. So this question led our study. So the data set. We have taken 3 major Lithuanian news sites, Delphi LT, 15 Min LT, and Alpha LT. We have taken articles from 1 week, and in total it was 3,500 of articles. We have taken articles from 12 categories. You can see 2D PCA of these categories. Interesting thing that at the right top corner you can see a lot of red X marks. These are from sports categories, probably because they are clearly separated, because many of those articles was from sports category. It was around 1/6 of the whole data set. And well, sports articles have a distinct vocabulary. This is our feature selection procedure. So basically, we split text into tokens, lowercase the characters, do the stemming. In some cases, we used token filtering by document frequency, also applied the term frequency, inverse document frequency metric, and normalized the feature vectors. We used several algorithms. These are k-means, 2 versions of k-means, classing and bisecting k-means, and also we used hierarchical clustering with 3 linkage methods: single linkage, group average linkage, and complete linkage. So the experiments and results. At first we tried to look into how stemming and inverse document frequency affects the quality of clustering. So inverse document frequency should remove the stop words, and stemming should remove morphological noise. And this seems to be true. The best results were shown by combining term frequency and inverse document frequency with stemming, and these results are approximately more than 50% better than all the other combinations of these 2. Next, we studied how the algorithms work and what's the quality of the clustering given by these algorithms. As you can see, these are average F1 scores. So the best one is k-means, and the second one is bisecting k-means. Close to them is hierarchical group average linkage algorithm. Unfortunately, complete linkage and single linkage hierarchical algorithms are closer to random clustering than to any of those 3. Also, if you would compare how F1 score depends on the number of clusters, you can see there is, with the red line marked, the number of categories. So in case of group average clustering, when the number of clusters comes closer to number of categories, the F1 score increases. This is not true for other 2 hierarchical clustering methods. Also, we tried to filter out some features using document frequency. This black line with circles is for k-means, and with triangles is for group average hierarchical clustering. So as you can see, k-means is barely affected by reduction of feature space. You can remove up to 90% of features, and it's still, the quality remains the same. Actually, it's a bit better than with 100% features. And in case of group average method, results vary much more, and you can see the trend of the quality getting lower of clustering with removing features. So a drill down look, we looked into we looked by ourselves into the clusters, what articles what articles fall in what clusters. We find a way to to get relevant words in every cluster. As you can see, there is a list of 10 clusters and 5 relevant words from each of the cluster. Even at short look, you can see, well, if you know Lithuanian, you can see, you can assume the theme of the clusters from all those words. So conclusions. So as expected, term frequency, inverse document frequency combined with stemming was way better than any other combination of feature selection. We have tested. K-means algorithm produced best clustering, and it also was barely affected by feature space reduction. There was barely any loss in quality, and after looking to the clusters itself, you can say that the clustering is quite sensible. However, there is some noise. So, and further work, we have been working on two-level clustering, using hierarchical clustering for making a lot of small clusters and then combine those using k-means. So this, we are working on this now. Questions?
How did you deal with the duplicates? I mean, some articles are the same in Dell and IVUS, so did you remove the duplicates?
No, we made no distinction. We just, yeah, we looked at those like two separate articles.
Any more questions? So thank you for your presentation. And also the best speaker award of the conference. Thank you very much.
So hello everyone, I'm Rita. I will present the paper Electricity Price Forecasting for Nord Pool Data. Because of the liberalization of power markets, electricity nowadays can be considered as any other commodity which can be sold and traded under the rules of power market. And our researchers on Lithuania's price zone in Nord Pool power market, which is leading power market in Europe. We begin with analyzing the price data, which was from 2014 till the end of 2016, and we noticed that electricity price has such features as high volatility, spikes, and seasonality. Using periodogram, we detected that there is seasonality weekly, annually, and daily. Out of these box plot diagrams, you can see that electricity prices also tends to be lower on winter and spring months, also on the weekends and night hours of the day. These dots above the boxes indicates the outliers, which is those extreme price spikes. In this period of time, the most extreme price spike was 300 euros, while the median of prices was around 40 euros.
For forecasting electricity prices in the literature, there are many different methods which can be grouped into 5 broad groups: multi-agent, fundamental, reduced form, statistical, and computational intelligence models. As it's the beginning of the work, we decided to start with benchmark models, statistical ones, average, exponential smoothing, and seasonal naive methods. So the results is for these 3 methods, we made forecasts for all days, for each day in 2016, and it is the lowest error, and that means the highest accuracy was achieved using exponential smoothing method, and it was 1.76%. However, the mean of this mean absolute percentage error was more than 16%. But due to the big number of outliers, maybe median, which was 12%, would better represent typical error. To show how the forecast works, this is the example how inaccurate can it be. And the actual prices is the solid black line with white dots, and this big line dashed is the seasonal naive method, as this method assumes that the forecast is the value of the previous period. This happens because in this case, the forecast was made for prices in Saturday, and Saturday tends to have lower prices. And as well as on Friday, there was a huge price spike, and this seasonal naive method just captured that spike, and therefore the forecast was so inaccurate. More typical cases like this one, you can see that seasonal naive and exponential smoothing methods can quite well mimic the volatility of electricity price during the day hours, but in case of a sudden price spike, it doesn't work well. As for the average method, it only works good enough if the prices are doesn't have feature of high volatility. So to sum up, during this research, we noticed that these prices have features such as high volatility, seasonality, and spikes, and it has daily, weekly, and annual seasonality patterns. And these simple statistical methods cannot perform well when it comes to capturing price spikes, as well as transition from weekday to workday, from weekend day to workday, and vice versa. And for the future work, we are planning to search for the best models and try statistical computational, more advanced statistical computational intelligence and hybrid models, especially with external data, as now we just tried with historical hourly prices. So that's it from me. Thank you for attention.
Questions, Martinez?
Okay, maybe I do have one. Since you had specifically daily patterns, were there any problems connected to daylight savings time?
In this case, daylight saving time wasn't considered, and it's like reading the articles, it's not that, doesn't consider it as a huge problem while forecasting. Yeah.
Okay, thank you for participation. Our next presenter, Samuel. Okay, you're welcome.
Hello everyone. My topic is investigation on road sign recognition, and I am Sam Gilvin, and my colleague is in India. He couldn't come for presentation. So my aim is to compare 4 distinct algorithms such as SIFT and SVM and HOG, Gabor filter and neural network, and blob analysis to find which algorithm works the best to detect road sign in terms of speed and robustness of the methods. So here is our task to review similar system of road sign detection to make implementation of chosen algorithms and compare 4 distinct algorithms called SIFT, SVM, HOG, and Gabor filter and neural network and blob. Methods, firstly we using SIFT to capture the image fastly to the segment. When we apply this Gaussian scale space function of d of x comma y comma sigma in Taylor expansion, we'll get this formula. And SVM classification is to classify the images for if it is in right or left, up or down. So HOG also is to classify the images. And UAF of Gabor analysis neural network is a feed forward back propagation neural network. Gabor filter using Gaussian technique for smoothness. FitNet method I can tell you later. SIFT, this is the implementation of technology. First we are using SIFT. This is the main concept of our algorithm. First we are loading input image and we are comparing input image with the image which we have in database and detecting key points can see in outputs, and finally we are matching the image to find doing extracting features. Finally we are detecting images. And second, SVM and HOG, same like SIFT, we are taking input image but it doesn't work with color image, so we are changing this to grayscale and we are doing some edge detection and smoothing out process. And here we are using watershed for to separate object from the background. So finally we are detecting the image here. And thirdly, Gabor filter neural network. Here we are using Gabor filter for Gabor transform. Train value has all values and test value it has only current value. It compare and perform the Gabor feature extraction, and finally it detects image. This is our outputs. Finally FitNet, this is the good result algorithm. So here we are doing the same like previous algorithm, binary image processing. We are here the morphological operation, it's mainly for it takes binary image and structural element as an input, and it combined with the set operators such as intersection, union. So it do like thing, and finally we are applying neural network, FitNet neural network training tool. It takes set of input and provides set of target outputs. So this is our output. After this process we are calculating a speed. We took 15 images here and we find out how many how long it takes to detect a image. So as per our decision blob analysis algorithm, it gives a better result compared to other algorithms. And secondly, we calculated robustness of the method, which means quality of the method. We took 30 images and we found out how many images detecting each algorithms. So blob algorithm, it detects 29 images, SIFT it detects 25, Gabor it detects 28, and SVM also the same. And here is our analysis of robustness and image detection time for 4 algorithms. So in conclusion, we compared and studied this algorithm, and image detection speed was in precedent order of blob. It takes 3.78 and Gabor 4.92, SIFT 9.56, SVM and HOG it takes 14.71. And comparing the above conclusion, it is observed that the blob algorithm was the best fit, followed by SIFT algorithm. Robustness of the method had a precedent of blob was found to be a highest, blob 96.6%, SVM 93.3%. It equals to Gabber 93.3%, greater than SIFT 83.3. So we propose fitnet function in blob analysis neural network algorithm. It gives best result compared to other algorithms. Thank you.
Any questions?
I have a question. Maybe I missed it in the presentation, but then can you maybe repeat where was the data set taken from? The images that you used for your classification?
For all images?
Yeah, what data, where did you take the data from?
In internet. So we took images in road sign, just Kaunas, we took pictures and we used that images, real images.
So, but there was a prepared...
Yeah, everything pre-prepared.
Any more questions? Okay, thank you for your participation.
Hello everyone, my name is Karolis, and I will talk about the algorithm me and my colleague Tautvydas, who has talked previously, created to calculate the Hausdorff distance metric efficiently. And I'm also going to present the research on the algorithm's performance and precision. There's a problem if you want to use Kinect device to track human skeleton, because the skeleton stream isn't accurate in positions other than standing. Kinect also has other streams available. Body index stream is quite accurate in all positions, but it is more difficult to analyze. And to analyze it, Hausdorff distance metric is quite useful. Hausdorff distance metric shows the similarity between two sets of points. For example, in this image we have a set of blue points and a set of red points. We calculate the distance for each blue point to the closest point in the red set and vice versa. And the maximum distance of those minimum distances is the Hausdorff metric. This raises another problem, because direct approach to calculating Hausdorff distance is complex. If we have a square or a near square frame, which Kinect does have, and its size is m on n pixels, which then the total amount of pixels is n to the square, and the number of required iterations is n to the power of 4. And another problem is that some applications require comparing frames different conditions. For example, the template and silhouette can be of different sizes, so we have to determine and match their sizes and also positions in the frame. For example, the template frame can have the silhouette on the left and the actual silhouette that we want to compare it against has the silhouette on the right. So we also have to match their positions. There are some existing solutions. One is created by Yanir Taflev and is used in a framework for shape comparison. One is used in Elasticsearch search engine, and one is created by Princeton University. And I'm going to compare my algorithm to those algorithms. Now about my algorithm. I have made one assumption that the template frame and actual frame will be vertical. They will have the floor as the bottom of the frame, so we don't need to rotate them. This takes out quite a lot of calculations, but it is, in practice, this is the most common use case. First of all, we have to find the best possible transformation between the point clouds. Let's say we have 2 point clouds A and B, and we want to match them as close as possible, and then find the Hausdorff distance, which is the minimum Hausdorff distance of all possible transformations. We need to find optimal scale S and optimal shift vector T. The formula is on the screen, but it doesn't directly say how to find those S and T coefficients. And the computation is quite intensive for large sets, so I decided to use heuristic algorithms to find them. If template and the actual silhouette are in similar positions, for example, they are both in standing positions, for scale transformation, we can use the ratio of their heights, simple as that. And for shift transformation, I have decided to use difference between centroids. Centroid is basically mass center when we consider all of the points of the same weight, the same mass. Then the final formula becomes quite simple. And if we make another assumption that only one person is tracked during the whole recognition process, we can cache these coefficients S and T, calculate them during the recognition on the first frame, and then use them in further processing. And this should speed up the recognition process even more. Now on to defining the actual Hausdorff distance. Once we made those transformations, the Hausdorff distance can be calculated. Hausdorff distance metric does not define what actual distance metric we want to use. So I have decided to use Chebyshev distance because it is fast to calculate. For both frames, for template frame and for silhouette frame, a matrix is created and every point is assigned a value. 0 if point belongs to the silhouette, and infinity if it does not. And all points with zero values are added to the queue, and then the queue is processed. We take a point from the queue, and we take a corresponding value for that point. Initially it's 0, but then we increase the value by 1, find all equidistant points to that original point. It is simply the square 3 by 3 around the original point, and if the original value plus 1 is less than the original value in that cell, we update it and add the point to the queue. And further queue processing bubbles out from the original points, and the whole matrix is calculated this way. Then we have to eliminate all the points that do not belong to another point set. If we have a template and we calculated this matrix for template, we have to eliminate all points that do not belong to the other silhouette. Because the purpose of this matrix is to show the differences between the two matrices, like the difference matrix. And once we eliminated those points, we find the maxima of both matrices, and the maximum value from both of them is the Hausdorff distance we have calculated. This value would be exact if we used exact, precise, optimal scale and transformation coefficients, but because we didn't, we use only heuristic algorithms, this distance will be approximate. I have used several optimizations. The most important of them is I only process the smallest bounding rectangle in the matrix, because most of the time the user takes only a third or 1/4 of the frame, so we don't need to process the whole frame, we only need to process the part where the silhouette is. And the two matrices can be calculated in parallel in separate threads, and this also adds to performance. Once I have those algorithms, I can measure their performance and accuracy. For performance research, I set up several test frames, 3 of them, and then scaled them to different sizes. The original size is the Kinect frame size, because this is my main application of the algorithm with Kinect, and I scaled from 10% to 300% in steps of 10% of the Kinect frame size. And one frame is the base frame, the template frame. It is the same for all comparisons, and other frames are actual user frames that we will compare against this silhouette, and one frame has the silhouette in the same position as the template frame, and the other has in different position, on the different side of the frame. And I have calculated the Hausdorff distance using the 3 algorithms that I showed from Elasticsearch, Yanir Tavlev, and Princeton University, and 3 versions of my own algorithm. Calculate the Hausdorff distance only, Hausdorff distance with computed transformation, and with cached transformation. For precision research, I used 21 different silhouettes. Then I created slow but precise algorithm to find the exact best transformation, and then compare the result against my own algorithm. So for performance comparison, the green line is Elasticsearch algorithm. It goes up the fastest. Then a little bit better is RGResolve from Princeton University. A little better is Yanir Tavlev's algorithm, and my algorithm performs quite weirdly actually. This might be because of parallel processing, but the curve is really lower than all of them, all of the rest. The speed of each version of algorithm is pretty much the same. Here on the diagram, on x-axis, 1 corresponds to frame size equal to the Kinect 2 frame size, and one of the y-axis represents my proposed algorithm's speed with Kinect frame size. And the value of 1 is 26 milliseconds on 5-year-old Intel i7 processor. And this is run against distant silhouettes. If we have close silhouettes, then the algorithm performs even better. And for Kinect frame, we have 21 milliseconds on the same processor. Precision test shows that transformations are in most cases quite good. Sometimes we get actual correct value. Average error is under 4%, median error is under 3%. And there were only a few cases with larger error. Maximum error was 15.5%. So to conclude, the proposed algorithm is faster than other open source alternatives that we can find on the internet. Larger than determination of execution time might be caused by parallel nature of the algorithm. It is fast enough to run at least 30 frames per second using Kinect compliant hardware, the i7 processor. Proposed transformation is accurate. So the median error does not exceed 5%. Algorithm works faster when we have close silhouettes that are in similar position in template and the user silhouette. An algorithm is suited for human position tracking and could be used to track position sequences, motions. So do you have any questions?
fast? Like how much is faster?
I have shown in this diagram. So it depends on Kinect frame size. But if we look at frame size of 1, then my own algorithm has the calculation time relative value of 1, and the closest competitor has value of almost 4. So
it's for 4 times.
Yes.
Okay. Any more question? Thank you for participation. Next.
So, hello to your attendants. I'm Darius Dirvanauskas and I'm going to present our research on embryo cell detection using regions with convolutional neural network. Briefly, introduction, why we decided to investigate the embryons. That 12% of couples in the world have difficulty getting pregnant. This percentage comes from men and women's infertility problems. There are different ways of treating infertility. It depends on the stage of that. First, let's use some medicines. If that won't help, there is intrauterine insemination, where when sperm is inserted inside uterus. And at the last stage is used assisted reproductive technology, when egg is taken from woman and its embryo is grown in the petri dish, and after a few days it's inserted to the woman. But success rate is low. Using assisted reproductive technologies, it's only 20-30%. It depends on many factors. Some of them are age of the partners, reasons for infertility, clinic's quality, type of IRT used, and if the egg or embryo is used fresh for embryo growing or frozen. When the egg is inseminated with sperm, it grows up to 5th day before insemination, and usually there is inseminate up to 10 embryos, and medics have to evaluate them at 3rd or 5th day to identify which is the best embryo. Usually we inseminate one embryo to prevent the multiple pregnancy, which could come from which come some complication. And we want to help medics for embryo evaluation. We want to create an algorithm for embryo cells quality evaluation, which will help them to be faster, because one medic has to identify multiple embryos for one couple, and at one time it's possible that it will be few couples. So first part of our research was to build the algorithm which will detect evolving embryo in the acquired image. We used data set size of 30,000 images of 15 embryos. We evolved up to 5th day. We randomly choose 1,000 images and manually labeled them. Labeled it in the image, and used up to 70% of data set size to train our method, and 30% of it for testing. For embryo detection, we use state-of-art method region with convolutional neural network. Our network consists of 30 hidden layers. So firstly, you want to know how much time it takes to train a network. We use a different amount of data set size to know training time results. As from graph, we see its training time is linearly dependent on training dataset size. After training, we tested how algorithm, here are some results, how it detects different evolved stages embryo. And the most important part of the results, detection precision. Network prediction was compared with expert prediction, and the smallest mean square error rate get on size prediction was get using 70% of data set size with yes, and smaller position, smallest error on position prediction was got used 65% data set size. It was only 4.62%. As you see from bar chart, the error is almost the same everywhere. But when we was using a small amount of training data set size, up to 30%, the network do not manage to find all of them embryos, so it's bad. Through some conclusions, what we made from our research, that training time is linearly dependent on training data set size. Our offered algorithm given 89.08% accuracy on embryo size prediction, and 95.48% accuracy on cell position prediction. At future, we want to improve our algorithm that it could count and evaluate embryo cells inside the embryo, and could evaluate the geometry of them and diameter. Thank you for your attention, and we have some questions. I do not want to go to the politics because I want to do science and want to help people.
But your science can help.
Yeah, we want to help, and we think that is a bad decision. So to not let to grow many embryos, and we have to keep them and frozen them. So.
Yeah, more questions? Thank you. Your paper is also the best paper of the conference.
Thank you.
And our last presenter showed us IVUS.
Okay, so good afternoon. My name is Evaldas Vaičiukynas, and I'm here to present a collaborative work with my master student, Aivaras Šimulis. So our topic is about Parkinson's disease detection from the voice signal, and the proposal we came up with was decomposing a voice signal into components and then proceeding with the audio feature estimation of them, and also using two levels of detectors. So we created an expert system as a prototype for this research. So the problem is that Parkinson's disease is one of the most common neurodegenerative diseases, which is quite frequent in the old age people. And at the stage when you usually medical personal diagnosis this, it's often is too late because many neurons are already lost. So there is a very deep need for early detection. And also there is some observations that speech anomalies can occur in Parkinson's disease patients quite early and up to 5 years before clinical diagnosis. So we need to do some non-invasive analysis of these speech and voice signals. And the goal is to create non-invasive tool for Parkinson's disease screening and hopefully monitoring, also providing medical decision support, which could be used for early detection or outcome of therapy or anti-Parkinson drugs. So the key points of the research is the subject's data we had was 3 recordings of quite short sound R, just up to 20 seconds, at a comfortable pitch. And the algorithms which we used for decomposition is empirical model decomposition and variational model decomposition. The feature set which we settled with was 12 perceptual linear predictive substrate coefficients. And the learner or the detector which we used was random forest. It was used both for base detectors and for meta learner to combine decisions from the base detectors. And also we used the variable importance from the meta-learner random forest for extra insights to know which statistics of the decisions are more important. And also we used some visualization from proximity matrix using T-distributed stochastic neighbor embedding, so as make a 2D map of the recordings. And the problem is quite relevant because it's hardly detected early, this disease, and our research relates to these fields such as computational intelligence and pattern recognition, and the research object is quite simple. These are these voice recordings. The related work in the field is a quite interesting article in 2016, which overviews all related work done before, so I would refer to this one to know what's happening in this field of Parkinson's disease detection from the voice and speech. And it recommends splitting speech into voiced and unvoiced parts as one of the conclusions. So challenges when we overview the related work are such that the size of database is quite a major problem because many of the databases are rather small. So biggest database so far, which actually was used in this research, is 88 Parkinson's disease patients and 88 healthy control subjects in German language. So another problem with the researches done so far is that they lack proper validation scheme, and by proper we mean that they should leave one subject out instead of just one recording out, because when you have several recordings from one subject you get biased and do not Parkinson detection but basically speaker detection. So sometimes it's not properly validated. And also main emphasis of all those researches is exploring different types of various audio features. And also nice news is that in InterSpeech 2015 they already included this task of Parkinson disease detection in a challenge. So summary of our database, when you can see that we have 75 Parkinson's disease patients and compared to the maximum biggest database, which is 88, so it's pretty decent, we could say. It's quite a good collection of voice samples. And of course we have lots of more healthy controls, because this database was collected from 2006, I think, so they collected healthy much more and only recently started collecting the Parkinson's. It was recorded in the Lithuanian University of Health Sciences, and we are thankful for their collaboration and sharing this database. It was done with a microphone, which is quite professional acoustic microphone, and in same conditions. Methodology which we use is based on some statistical functions which are used for baseline solution when we have frame-based audio features to compress them from all the recording. And then we proposed to extract several windows from the recording and use those windows for decomposition, and then for each window and each type of decomposition we create base detectors, and the decisions from those base detectors are later compressed using the same statistical functionals. So the two solutions which we compare are very simple, using all the recording, and another is using only specific parts of recording and doing decomposition and going deeper. So we wanted to see if there's a difference in accuracy. And the features are calculated from each decomposed intrinsic mode function. This is a result of the decomposition procedure. And then we use random forest and evaluate the goodness of detection. And also some prototype is in the final stage created. So the idea which we proposed is taking a window from a recording which is quite short, from 5 to up to 100 milliseconds, and then we take this window and split into components. So basically they are of varied frequency, with more frequent and less frequent fluctuations. And then we calculate for each of that component those frequency-based audio features. So in the final feature vector for the base detector, we have both the frequency-based features from the non-decomposed window, and also we append for each component its own feature signature, frequency signature. And then in the next level, we create those base detectors. From base detectors, we get a decision for each component, and then we compress those decisions using statistical functionals. And in the second stage detector, which is meta random forest, we use these compressed decisions from one kind of decomposition and from another kind of decomposition. So the composition techniques which we have chosen, they are implemented in MATLAB, and they are quite new, those implementations. And the idea is to split the original signal window into components of varied frequencies. So this is the main idea. So we kind of go deeper into the signal. And then we calculate this frequency signature, which is just an improvement over mel frequency substrate coefficients. And the improvement is basically on the filter bank shapes. When they have such filter bank shapes more similar to the human voice. So it's basically was adjusted for human voice. That's why these coefficients were proposed. And the detector we use is random forest based on many decision trees. So the number of trees we use is 5,000, and the number of features in each node to choose for splitting, they are chosen randomly. So the number of features chosen randomly is square root from the dimensionality of the feature matrix, or the size of the feature set, and then twice bigger setting, and then half of the features. And we choose the best parameter. Then we get proximity matrix from the meta random forest. We convert it to distance matrix and use it for visualization. So the idea of random forest is quite nice, and it is efficient and quite robust against overfitting. Additionally, it has out-of-bag validation, which makes you no need to do cross validation by splitting into faults. And additionally computes proximity matrix, which we use for visualization. And in 2 words, this idea of random forest can be said that it's bootstrap aggregating by building each tree on a different subsample of data, and then random subspace by taking randomly some part of features and then using them for splitting each node of the tree. And for decision level fusion, we take the difference between class probabilities. So base learner is specifically built for each decomposition and also for each window location. And meta learner combines those decisions from base learners. So to measure the goodness of detection, we use equal error rate, which is the point on the rock or dead curve, which is on the diagonal. Basically, when one class accuracy is equal another class accuracy, or when the error of one class is equal error of another class. So one class is healthy, another class is Parkinson. And the more comprehensive measure we use is also cost of log likelihood ratio. So it's a little bit related to cross entropy and or also to area under the curve. So it integrates this curve throughout all length. And finally, the experimental setup and experimental results. So we chose to try one window, two windows, or three equally spaced windows from the recording. So the location was predetermined by this equal spacing. And the initial results were best when we combined both the compositions. And the size of the window was 30 milliseconds and quantity was 3 windows, but also one window gave also surprisingly good equal error rate, which is 2.22. So we are kind of suspicious of this result, of this initial result. And we later repeated experiments to see what is the more real equal error rate. So when we plotted it against window size, we can see that for baseline solution, the best equal error rate we can get was around 33%. And for our proposed solution with this 30 milliseconds window size, it was 2.22. So we had also to do sensitivity analysis if it's accidentally or not. But you can see quite strange drop in that error at this window size. So for visualization, we use proximity matrix, and actually this confirms our good accuracy, nice error rates by splitting the recordings into clusters. So we can see the cluster which is red, this is Parkinson disease recordings, and then cluster which are blue points are the healthy ones. And also out of curiosity, we just tried to see the variable importance to see which statistics were most important when compressing decisions from base random forest. So it appears that variance-related statistics were very important for the meta-random forest. And for sensitivity analysis, we repeated experiments several times. So because the nature of empirical model decomposition or variational model decomposition, it's a little bit stochastic, and each time we get not identical those components, intrinsic model functions. So we repeated this decomposition runs 5 times, then 5 times we repeated construction of base detectors, and 5 times we repeated the meta-learner training. So in total we had 125 runs, and we compared one window with a 3-window setup. So we found that with 3 windows we can reach the average equal error rate of 6.5. So actually those initial ones were quite optimistic results, and after checking with many runs we found it's 6.5 equal error rate. And also we did median comparison with a non-parametrical Wilcoxon-Rank-Sum test and found that medians are significantly different, and you can clearly see that from the plot. And for the prototype, IVUS designed some requirements in UML language, use case specification, activity diagrams, and finally implemented this as a web-based solution to upload a WAV and obtain the diagnosis. So diagnosis is basically the probability of Parkinson, and also the result of this is this picture. You can see where you're recording as a point, like you are here. So you can see if you are closer to the Parkinson's, if you are closer to the healthy ones. And conclusions is that baseline solution, when we use all the recording and don't do any decomposition, is equal error rate around 33%. Now with proposed solutions and using 3 windows, we got average equal error rate of 6.5. And we would recommend fusion of 3 windows and then also use both decompositions. And the variational model decomposition was found as slightly better and giving better accuracies. And from variable importance, we can say that variability related or variance related statistics are the most important when compressing the decisions. And for future work, we would like to repeat the decomposition and feed all the components we extract to the base detectors. So basically, base detectors would have more data. And also meta-random forest would be enriched by more robust statistics, because when we get decisions for the number of components, and we have 7 components, and we calculate statistics from 7 decisions, so when we do this repetition, we could get statistics from, let's say, 25 of components when you repeat the decomposition. And we would like to do this test with recordings from smartphone, and also we would like to cross-check these results with some other voice database like Empower. So, thank you for your attention.
Do you have any questions?
First of all, thanks for a very serious presentation. Actually, I have two questions. One is, in your training data set, how balanced are the samples? How many healthy people you have, and how many Parkinson's patients? And is there a way to, how is this decided? What's the technique here?
So number of patients was 75 Parkinson's and like more than 3 times more healthy ones. Mm-hmm. So it was not so balanced. And then number of recordings, we can see that we have 223 recordings for the Parkinson's, so like 3 recordings for each patient. But what we do for evaluation, we use out of bag from random forest, and we specifically change the algorithm so that it does it in a proper way by splitting the recordings so that all recordings are either of one patient are either in bag or out of bag. But it was not balanced exactly, and then we used also stratification.
Yeah, so I don't know the correct answer to this question either, because in diagnostic setting you would also hopefully won't have half of all the people with Parkinson's. So.
Yeah, but it's not half; it's much less.
Yes, so
I understand your point. Yeah. And also we calculate the equal error rate, so it's for both classes it's the same.
Okay, that's a very nice approach. My second question is, when you made the web-based application where you can test yourself, so basically the patient uses his own microphone for that?
Yes, it's a bit problematic because you can have different quality microphones, and these were done with a single microphone. All the recordings were collected. So it's a bit, channel, changing the channel.
I also have one question. I found quite interesting that there were 2 quite distinct clusters of healthy people.
Mm-hmm.
Maybe you checked what was the reason? Maybe gender differences, age, or difference in equipment?
It could be gender, but we haven't checked it. Sorry.
Any more questions? So thank you, Heraldus.
Thank you.
It's also the test paper of the conference.
Oh, thanks.
Thank you for participation. And thank you everyone for your patience and your dedication today in participating in this conference, and I hope we will meet next year. Goodbye.